Section 2.4, homework problem number 17. All right. So some students, you might have students who will compare fractions this way. So they compare the top number and the top number, the numerator and numerator. So they compare these two, say, okay, well, the 8 is bigger than 7. And then they will compare the denominators. 11 is bigger than 10. And that's why 8/11 is bigger than 7/10. Well, so this some students may try to argue this way, try to compare fractions this way. Although in this case, yes, it does. It is 8/11 is actually bigger than 7/10, but the argument, the reasoning is incorrect. Because his reasoning, it somehow worked for this one. Again, it's a coincidence. It doesn't work on others. And we did have examples in class. So, for example, you can look at the one I have. Again, when you do this problem, let's see, the questions is, first of all, you have to answer, is his reasoning correct? So you need to answer yes or no, okay? Secondly, if it is correct, you explain why this is correct. Second, just like we did with this, okay, you have to compare the number of parts and the size of each part. And actually, his reasoning is incorrect. So it's not going to work. And if it's not correct, give 2 examples. We call them counterexamples. What kind of examples? The example you give us are going to tell us his reasoning is incorrect. Okay, so here I give you one example, and I'm going to ask you to come up with your own examples. Okay, so again, this is not an example. This one, the 2 fractions given somehow showed his reasoning is correct. It seems like, well, his reasoning is correct. But what we want to tell Malcolm that your reasoning doesn't work for a lot of other problems. Okay, for example, I gave these 2 fractions, 2/5 and 1/2. And if we try to use Malcolm's reasoning, let's say, okay, let's compare the numerators, denominators. 5 is bigger than 2. Okay, so 5 is bigger than 2. And then let's compare the numerators, 2 and 1. Okay, 2 is bigger than 1. If I use Malcolm's reasoning, I would get the conclusion I should. So this is Malcolm's, not mine. Okay, so Malcolm's, oops, I spelled it wrong. Reasoning. If I use his reasoning, I should have 2/5 is greater than 1/2, which is incorrect. Okay, although it did work for the 2 fractions he picked, it's not correct. Okay, because it doesn't work on the 2 fractions I picked. And again, why we know 2/5 is actually less than 1/2, and why is that? You could use common denominator, cross multiply, common numerators, whichever way you want to use. So I'm just going to do a quick common denominator. So I'm going to multiply this one by 2, this one by 5, so I can get the same denominator, 4/10 and 5/10. And notice that 4 parts is less than 5 parts if they have the same sizes. The slices are the same. So that tells me 2/5 is smaller than 1/2. It's not bigger than 1/2. So if I try to use his reasoning, I'm going to get the wrong answer. Okay, and so this is incorrect. Okay, so I should probably label this incorrect. Okay, and so again, the correct way to compare fractions is you have to compare the number of parts. So if 2 is bigger than 1, yes, okay, you have more parts. So let me write down those 2 key points again. Number of parts, which are determined by the numerators. So 2 is bigger than 1. But you also have to compare the size of each part Well, if you have a 5 as a denominator, a bigger number, what means everybody gets a smaller share. Each slice is going to be smaller. Okay, so although you have more parts, let's say you have 2 slices of pizza, but each slice is tiny, it may still be smaller. It's actually, in this case, is still smaller than 1 slice. Okay, so even though you have 2 slices, but even when you put them together, it's still smaller than 1 slice. The reason is the denominator is 2, which means only 2 people are sharing one pizza, and each of them gets like half of the pizza, which is much bigger than 2 slices. Each of them is 1/5. So you will not be able to compare them just the top and bottom and bottom. Okay, so but all you have to do is, first of all, you need to remember that his method is incorrect, and also you need to give what we call a counterexample. What's a counterexample? You will give 2 fractions, and that do match the conditions. So he is saying like top is bigger than top, bottom is bigger than bottom, but the entire fraction with bigger top, bigger bottom is actually a smaller fraction. So in this case, it's not bigger than, it's actually smaller. 2/5 is actually smaller than 1/2. So that tells us his reasoning is incorrect. Okay, so that's called a counter example. So there are fractions like this, like these two. Actually, somehow it worked. 8 is bigger than 7, 11 bigger than 10. That means that actually did 8 11th is bigger than 7 10. But it's not because of his reasoning is correct. It's because when we do multiply 10 here and multiply 11 here, 80 is bigger than 77. It's just because the numbers he picked happen to be correct for using his reasoning. But it's not because of his reasoning is correct. Okay, all right, so that's you need to come up with 2 examples. If you have trouble finding examples, a tip that I can give you is make sure this bigger number is much bigger than the other. For example, the reason his is correct is 11 is only 1 bigger than 10. But if you change 11 to like 17 or something much bigger than 10, his reasoning is going to be wrong. Okay, so if you have trouble, you can try that. So like my 5 is 3 bigger than 2. Okay, so if I pick 3, 3 is only 1 bigger than 2, and it's not going to be a counterexample.